16 miles, and it's a circular
Yeah.
sort of a building.
Yeah. Well, it's a big tube. I mean, you think basically it's mainly under France and partly under Switzerland, and it accelerates protons around in a circle, both ways. One beam goes one way, one goes the other way, and they go around 11,000 times a second. So that's very close to the speed of light, 99.999999% the speed of light.
Neutrons will most likely vanish on other worlds as well if they do. Though it may sound absurd, individuals are actually attempting to use this physics. If the balance of truth existed outside of reality, just think of how different the world would be. Will it take us as long as getting on a train to hop from one state to another? Do you really believe that every decision you make has the power to alter the course of your whole life? The world is not different because of your decisions. After all, there are a lot of different universes out there. And maybe you are unique. It's possible that the idea of being in several dimensions is incorrect. A startling finding on the potential to open a portal to another dimension has been made by CERN. What impact will this have on us? Is it feasible at all? Above all, what impact does this have on the structure of space and time? Come along as we examine the intriguing and frightening research being conducted at CERN. Responsibilities of CERN. In order to comprehend portals, dimensions, and objects completely, we must first comprehend the nature and functions of CERN. The European Organization for Nuclear Research, or CERN, is a utopia located in the center of Europe. Since the 1950s, the research center has been situated in the picturesque area near the French-Swiss border. To establish CERN, 4,444 delegates from 12 European nations convened in Paris with the exclusive objective of constructing a nuclear research facility that would propel Europe ahead of discoveries. Major global initiatives that CERN has worked on throughout the years include the Large Hadron Collider, LHC, in 2008 and the World Wide Web in 1989. With a radius of almost 17 miles, the Large Hadron Collider is buried far below the surface of the planet. It is furnished with detectors, magnets, experiments, and more apparatus. It is the biggest and busiest particle collider in the world. Hundreds of institutions, laboratories, and over 10,000 researchers work together to establish this hypothesis. The process of particle collisions and the Large Hadron Collider. Episode first. Let's talk about the LHC. It is the biggest and most potent particle collider in the world. It is astounding that this lovely business was developed by 10,000 scientists working in hundreds of labs and colleges. It's buried in a 17-mile tunnel close to Geneva, 574 feet below the Earth's surface. 2010 saw the first collision at the Large Hadron Collider, with 3.55 TeV of energy per line. However, before reopening in April 2022, the LHC was shut down many times for maintenance and improvements, including in 2013 to 2015 and in 2018. Because of these consistent outputs, the LHC's beam level energy was raised from 3.5 TeV to 6.5 TeV in order to preserve its standing as an accelerator and collider for high-energy particles. By sensing various scenarios surrounding junctions, 4 intersections and 9 detectors make sure the LHC is operating at peak efficiency. Methods of particle collisions. The process of particle collisions is arguably the simplest for studying the most significant component of the cosmos. In short, we take these massive machines and dismantle stuff to see what occurs. It's a fairly primitive approach, but it gets the job done. Our tools and techniques, however, set humans apart from Neanderthals. We have accelerators that can accelerate objects to near-light speeds in place of rocks and fossils. The LHC uses radio frequencies in this multi-step procedure to accelerate the material to almost the speed of light. When these items approach 0.9999991 times the speed of light, just 3 meters per second faster than the speed of light, a superconducting magnet will regulate their spin, Injecting the substance into a linear accelerator or linear accelerator is the initial step. Charges things at a rate of about 50 million volts per electron. Once inside the accelerator chamber, the object's energy is progressively increased to trillions of electron volts, TeV. Proton synchrotron booster, proton synchrotron, and superproton synchrotron are a few of these boosters. Ultimately, the particles get energy of up to 7 TeV from the two main rings of the Large Hadron Collider, whose circumferences are 27 kilometers apart and have a magnetic field of -71.316666. These particles then collide and strike the head of the difference. We may see intriguing properties of objects, such as the production of new ones or the release of energy, thanks to these high-energy collisions. These findings aid in our comprehension and enlargement of the cosmos. Many items were produced by these collisions, some of which had never been observed in a laboratory before. How are these small ones going to be assessed? Particle route is tracked by detectors positioned throughout the collider to determine the particle's strength, kind, and strength. We can identify the features of the items that have been discovered and carry out additional behavior analysis by examining the design of these products. I wonder how things in the Large Hadron Collider avoid hitting one another when they collide. How can they conduct honorably, given their little size? Particles at the Large Hadron Collider are observed to be carefully packed into needle-shaped packets, which are crushed to produce collisions. It is estimated that there are just a few collisions between two packets every collision, and that each needle contains around 10^11 protons. Their totals sometimes exceed millions of dollars in a single day because of the frequent crashes. However, despite this design's remarkable qualities, there were early reservations about the LHC. There have been worries about the LHC for a very long time, nearly since it was built. People have been terrified of black hole development and worried about how it would impact our planet since its inception. Unexpected findings have been made as a result of innovation and research continuing despite the recent discovery of the Large Hadron Collider. For instance, scientists discovered the X particle, a mysterious basic particle, early in 2022. More precisely, it's X3872. Originally detected in 2003 by Japan's Bell experiment. Particle colliders were used in this experiment to combine high-energy electrons and positrons to create the enigmatic X particles, but they finally destroyed too rapidly to be thoroughly examined. Later on, it was suggested that quark-gluon plasma might provide a superior illumination for X3872. By 2022, fragmentation of Li ions in quark-gluon plasma culture had yielded around 100 X particles. These items are thought to have existed briefly close to the Big Bang. The results were released in the journal Physical Review Letters on January 19. Did you know that the universe consists of far more than simply the planets, stars, and galaxies that we can see with our naked eyes? As a matter of fact, it represents a mere 4% of all available data. The space surrounding objects, rather than the objects themselves, is the fundamental definition of the cosmos. Researchers have found that most of the cosmos is made up of objects that are invisible to the naked eye. There is no light or other radiation that glasses can detect emitted by these invisible gadgets. Rather, their only reason for detection is because they obstruct stars and galaxies' gravitational motion. This unexplained material is known as dark matter or dark energy. Though their specific nature and kind are yet unknown to us, they present intriguing opportunities for new physics discoveries. About 23% of the Earth is composed of dark matter. When galaxies began to move in ways that suggested there was more to us than what we could see in 1933, we began to believe it existed. Though there are several methods to engage with dark matter, we are unable to directly view it or interact with it. You may think of dark matter as a killer running from the scene. Scientists look for blood traces throughout the crime scene investigation, which provides us with a rough estimate of the amount of blood present. What then is darkness composed of? It could be composed of items that are supersymmetric to start. These items are symmetrical, but orientated in opposing directions, similar to the hidden partners of the known objects. With the use of experiments like the Large Hadron Collider, scientists are attempting to discover these. Let's now discuss dark energy. Dark energy is one of the most significant components of the cosmic drama, accounting for around 73% of the universe. It appears that dark energy permeates everything, even the void seen within galaxies. Naturally, unlike dark matter, there isn't local gravity, but there is another phenomenon. The force responsible for the universe's gradual acceleration and expansion is known as dark energy. By calculating the galaxy's distance from us, we can gauge its expansion. These findings confirm the presence of dark energy and provide insight into its workings in conjunction with other scientific evidence, even if it is hidden from our immediate view. At last, the Higgs boson particle has been found. In physics, the Higgs boson is a little-known yet critically significant phenomena. This product was originally mentioned in a scholarly paper in 1964. One wonderful science that helps us understand the idea of balanced reality is quantum field theory. Envision the cosmos as a vast space populated by little players, known as the particle cosmic theater. As previously stated, these items move and communicate with one another like actors. Like a spotlight on a stage, each particle has a specific location according to quantum field theory. Everything is filled with these fields, including the empty space. The realization that things do not move on the same level as billiard balls is a breakthrough in quantum physics. Alternatively, they could materialize and vanish swiftly, like two performers wildly applauding on stage. They interact with the environment in this way, bringing about constant change. We may better comprehend the behavior of things and fields and their interactions by using mathematical equations that create complicated rules governing these interactions. To put it plainly, quantum field theory is a script for comprehending how particles or actors and fields interact continually and in seemingly endless ways across the cosmos. The Higgs boson was so hard to detect that it took nearly 50 years to find it. It is 120 times heavier than a proton in weight and vanishes in less than a second, indicating its extreme gravity. Scientists must do their own research in the lab to find out. Launched in 2010, the Large Hadron Collider is the first facility big enough to generate a significant amount of Higgs bosons. However, the discovery of the Higgs boson is only the start. It immediately divides into other entities when it is generated. Since scientists are unable to observe it directly, they must identify the substance through which it flows. The issue is that several previous trials have shown similar results. Merely seeing these items does not establish the existence of the Higgs boson. Furthermore, in just one of the collisions does the Higgs boson form. Thus, the task facing scientists is to determine if and when these particles originate from the Higgs boson. It's similar to trying to discover a needle in a haystack. However, instead of doing so, they have to provide evidence that the needle is present. Though it's a challenging riddle, scientists have devised a cunning solution. Although they were unable to locate the straight needle, they were able to deduce its location from the haystack. The Higgs boson is referred to as the God particle due to its significance in comprehending the functioning of the cosmos. The term damn particle was coined by physicist Leon Lederman in jest in the 1990s when he was having trouble finding the particle, and it stuck. In his book, Lederman describes the Higgs boson, first referring to it as the damn particle. However, the publisher later renamed it the God particle, which is what some people think. However, the Higgs boson is crucial. There wouldn't be any mass without it, which means that there wouldn't be any stars, planets, or humans. It is most likely deserving of its unique moniker for this reason. Furthermore, the finding is still ongoing. We've been thinking of three-dimensional space as a big box with height, breadth, and depth in our daily lives for a long time. When Einstein declared that time may be thought of as the fourth dimension, everyone was taken aback. However, some people now wish to go farther with it. Though they are too tiny for us to perceive, string theory says there could be 6 more. We cannot see them because they are so little and coiled up, even though they may be all around us. This theory is used by some scientists to attempt to solve a major puzzle. Why is gravity weaker than other forces? We may not completely experience the impacts of gravity in our daily lives since they are dispersed throughout the hidden cosmos. Thus, how are we to test the invisible? Through high-energy object investigations, CERN thinks scientists will be able to see long enough into these dimensions to detect items moving an extra length on our 3-dimensional Earth. This might manifest as a little object unexpectedly appears during testing or vanishes from a concealed location. The potential for another realm. This is the situation in which parallel dimensions become useful. As you can see, a lot of the tests carried out at CERN have raised questions in the past and continue to do so now. One of the youngest people on the planet, Max Lowlin, shares his opinions about what CERN can do and how scientists may use it. The shocking thing about the European Organization for Nuclear Research, CERN, is that many of the experiments it conducts involve accelerators, which has influenced our reaction globally. Some of the things this young man mentioned go against the views of scientists. In addition to being referred to as the youngest man in history, Max Lowlin is regarded as the world's brightest child. He created an energy harvesting gadget at the age of 13 that didn't require oil, coal, or solar energy. Some even suggest that Max will undergo a metamorphosis and draw comparisons to Nikola Tesla. Lowlin thinks that although our world could have been destroyed by CERN, it has since changed as a result of several experiments with object accelerators. Max, who is well known for his perceptiveness and inventiveness, believes that CERN experiments might have an influence on how we live. In his podcast, Joe Rogan discusses a lot. Joe Rogan covered a wide range of subjects and welcomed several celebrities, including Sean Carroll. Sean Michael Carroll is an American physicist and philosopher with expertise in quantum mechanics, cosmology, theoretical physics, and other related fields. His research findings have also been published in scholarly journals including Nature, New Scientist, Sky and Telescope, and New York Times. The podcast emphasizes the need of maintaining the balance between the content of multiple dimensions and the truth. Carroll, attempting to put things as simply as possible, stated this. He clarified that the behavior of tiny particles, like electrons, is the subject of quantum mechanics. However, things tend to become stranger when you get into it more. You see, massive object motion was the subject of classical mechanics, which existed prior to quantum mechanics. But the game was altered by quantum physics. He stated that the electron is more than a wave as opposed to describing it as a little ball with location and speed. After expanding to the desired measurement, it clicks into place. Things start to become extremely chaotic at this point. Looking at the generator is similar to tossing a coin. Until you see it, you won't know if it comes up heads or tails. Depending on your perspective, everything is different. This is the rationale behind the multiple worlds theory, a theory put out by some. The truth is that the world divides into many categories whenever something occurs. Therefore, in one universe you will select Chinese food, while in the other pizza, if given the choice. The problem is that since they are unable to communicate, you will be ignorant of what occurs on other planets. The podcast explains the astounding physics behind the Large Hadron Collider and its experiments, which will lead to discoveries that will help us get closer to many dimensions. Consequences for the future. This raises the issue of what lies ahead for us. Can a doorway to another dimension be opened by CERN? Their website claims that they handle these kinds of situations. According to some scientists, there exists a tiny particle known as a graviton that functions similarly to photons, operating on the electromagnetic force in the same way as a gravitational fluid. The Large Hadron Collider should be able to produce gravitons if they are real. However, they will vanish into another dimension very shortly. Particles from the Large Hadron Collider blast out like rockets in all directions when they clash. Unnoticed graviton collisions will result in differences in the energy and speed of the event, providing clues to dimensions beyond our own. To find out if this is graviton escape or something else, like dark matter or unusual objects, we need to closely investigate this discrepancy. To locate the cosmos, one further method is to produce tiny black holes. The amount, size, and number of additional dimensions that are involved determine what we may observe from these black holes. These small black holes would not leave much of a trace on our detectors, but they would vanish fast if they emerged at the LHC. Learning more about them might lead to new and uncharted territories. What are your thoughts then? Is this happening for real, or are we getting close to Marvel's multiverse madness? Please share your opinions with us in the comments section below, and remember to like and subscribe to the channel. Until we meet again.